Okay, for this video, we're going to go over how to identify the slope and y-intercept in an equation and match it with a graph. So in this particular problem, we're looking at 3 different linear equations, all in slope-intercept form, and 3 different graphs. Each one will match one of the equations. Before we get into how to match them, I want to go over quickly slope-intercept form of a linear equation. So this is what our equation looks like, y equals mx plus b. M right here is going to be our slope. So it's the change in y over the change in x. Basically, that just means for every 1 unit, we're going right. For every 1 unit we're going right, how many units are we going up or down? If we go up, it's going to be a positive slope. If we're going down, it's going to be a negative slope. The b in our equation, this is our y-intercept. Essentially, it's the point where x equals 0, what is y? If we're looking at a graph, it's basically where the line crosses the y-axis. Okay. Now again, this is a linear equation, so it will look like a straight line. It'll have constant growth or decay. So if we were looking at these and one of our graphs had a line going like this, none of them will match it, right? Because that's a curved line, an exponential line, not a linear line. Okay, so let's look at our equations first. I'm going to highlight the slope and y-intercept here. Slope in green, y-intercept in yellow. And then we'll match it with the graphs. So first equation, we have y equals 1/3 x plus 3. So our slope here is going to be that 1/3 x, and it's a positive slope. So our line is going to look like it's going up. Second equation, we have y equals 3x plus 3. Our slope here would be 3. So again, this one is positive, so the line is going to look like it's going in an upward direction. Here we have y equals negative 3x plus 3. So the slope here is going to be that negative 3. So instead of going up this time, we are going to be going down. Okay, now let's look at the y-intercepts of each of these equations. So the first one, we have a plus 3. Second one, plus 3. Third one, plus 3. So if you look at each of the graphs, all of them have a y-intercept, so where the line crosses the y-axis, at a positive 3. So each of these have the point 0, 3, 0, 3, and 0, 3. So to match them, let's look at the slopes. Since all of the y-intercepts are the same, that doesn't really help us here. So if we look at the slope for the first equation, we're going to be going, essentially, remember that slope is going to be, not the sloper, the slope is going to be your change in y over your change in x. So let's look at the first graph. For every 1 unit, we're going right. So 1 right. We are going 1, 2, 3 up. 3 up. So our slope in this graph is going to be 3. Now you could write it 3 over 1, but it's the same thing as saying 3. The second graph, for every 1 unit, we're going in the right direction from this point to the next point. So 1 unit right. We are actually going to be going down this time. So 3 down, or if you put it just in numerical form, that would be a negative 3. Negative because we're going down. Okay. Last graph. Now we could talk about this as for every 1 unit we're going right, we're going up, it looks like some fractional amount. So instead of doing that, I'm actually just going to look at our next obvious point on the graph, which is right here. Okay, so if we look at our graph, here we're going right 3 units. 3 units right. And for every 3 units we're going right, we're going up 1 unit. So in this case, our slope is going to be a fraction. So it'll be 1/3. Okay. So now to match our equations with our graphs, let's use blue. So the first equation, y equals 1/3 x plus 3. Again, all of them have the same y-intercept, so that doesn't really help us identify. But here we're looking at a positive 1/3, so it's going up a fractional amount. So this first equation is going to match the last graph. Now, if we look at the second equation, we again have the same y-intercept, but this time our slope is 3. So for every 1 unit we're going right, we're going up. Keyword there is up 3. So the second equation is going to be matching that first graph. And for the grand finale, the last equation, same y-intercept, but the slope is negative, which means we're going down this time. So that last equation is going to match the second graph.